This is paper 4-2 Mechanics of Winter 2023. The first question. A block of mass of 15 kg slides down a line of greatest slope of an inclined plane. The top of the plane is at a vertical height of 1.6 meters above the level of the bottom. Speed of the block at the top is 2 meters per second and at the bottom is 4 meters per second. Find the work done against the resistance to the motion of the block. So before actually solving the question, we need to understand what is happening. So there is a slope, a block is at the very top, the height of the block is 1.6 meters. On 1.6 meters, they did not provide us with any angle, and the block is moving down. Since the block is moving down, the speed of the block increases from 2 to 4. Speed increased from 2 to 4. This means it gained kinetic energy. You also need to understand that the block is moving down due to the weight component. And since the weight component is doing work, or in other words, since the block is moving down, GPE is lost. And we know that energy is always conserved, Keeping that in mind, we can form the equation that energy lost is equal to the energy gained. So, what energy is being lost in this question? The gravitational potential energy is lost as it moves down. And since it's moving down, it is gaining kinetic energy since the speed increased, and also it does some work against resistance to the motion. Thus, keeping all of these in our minds, we can form the equation that GPE lost equals to the kinetic energy gained plus work done against resistance, which is WR. So just writing the formulas for each, GPE lost is nothing but mg del h equals to KE gain, so half m del v square plus WR, just a variable. And now just inputting the values. Mass was given 15 times 10, the value of g, times the change in height. It started at the very top and ended at the very bottom, and the difference in height, or the difference in heights, was given as 1.6. So del h is 1.6 equals to half times the mass 15 times del v square. The speed increased from 2 to 4, so we can write 4 square minus 2 square plus WR. Now we just solve and find WR. 15 times 10 times 1.6 is 240. This is the GPE lost. This must be equal to the KE gain and work done against resistance. So half times 15 times 4 square minus 2 square is 90 plus WR. Therefore, WR is equal to 240 minus 90 equals to 150 joules. Question 2. The diagram shows a smooth ring R of mass mkg threaded on a light inextensible string. A horizontal force of magnitude 2 Newton acts on R. The ends of the strings are attached to fixed points A and B. The part AR of the string makes an angle of 30 degree and BR makes an angle of 40 degree, the vertical, and the string is taut. Since the string is taut, it means tension is present And it's also stated that the ring is in equilibrium. Since the ring is in equilibrium, it means resultant equals to 0. Since resultant equals to 0, I can form a few equations or a few generalized equations. That is the total or the resultant vertical. So resultant vertical force equals to 0. This means the downwards force equals to the upwards force. Similarly, the resultant horizontal force is 0. So that means the force towards the left is equal to the force towards the right. This means if I can form two equations regarding the vertical and horizontal, I will be able to solve this question. So since tension is present, I need to determine the direction of tension in the strings. We can sort of think that R, the ring, is acting as a pivot, and the string is divided into two parts as already stated. And I can also draw a line to represent the weight of the ring, which is 10m. So to determine the direction of tension, I need to focus on the fact that it is in equilibrium. Since it's in equilibrium, the 2 Newton force that is towards the right must be cancelled by the horizontal component of tension. Since the weight does not have a horizontal component. That means tension has a component towards the left. And to fulfill that criteria, tension must be acting towards the top left in the top section and must be acting at the bottom left for the bottom section. So I have found the direction of tension in each section. Now I must break down the tension to its vertical and horizontal components. To find the vertical component for the section AR, I've already formed a right angle triangle. I need to find the vertical of this right angle triangle. Since this is adjacent to the 30-degree angle, I can say this is d cos 30, and this force is acting upwards. Similarly, for the bottom section, the vertical is adjacent to the 40-degree angle, so I can say that is t cos 40, and this is acting downwards. So the vertical components have been found. Now to find the horizontal components, the horizontal components are both acting towards the left, and they are the base of the right angle triangles. Since they are opposite to their respective angles, 30-degree and 40-degree, I can say the forces are d sine 30 plus d sine 40. This is the horizontal component of tension. So now that I have the components of each force, I can start to form the required equations. So using the vertical forces, I can say that 10m, which is downwards, I'll add the downwards forces together. So 10m plus t cos 40, this will be equal to the total upwards force, in this case the vertical component of the section AR, so t cos 30. So 10m plus t cos 40 equals to t cos 30. This is one equation using the vertical components. Now using the horizontal components, the rightwards force, which is 2, this will be equal to the horizontal component of tension. So t sine 30 plus t sine 40. Since this second equation only has one variable, which is t, I can already solve for t. So 2 equals to t bracket sine 30, taking t common, sine 40. Therefore, t is equal to 2 divided by sine 30 plus sine 40. This will be equal to 1.75 Newton. So now that I have the value of t, I can input this value in the second equation to find my value of m. So using that idea, I just input the value. So 10m plus 1.75 cos 40 equals to 1.75 cos 30. There are 10m equals to, taking this to the right, 1.75, and taking 1.75 common, cos 30 minus cos 40. Now just to solve for m, therefore m is equal to 1.75 by 10 times cos 30 minus cos 40 equals to 1.75 cos 30 minus cos 40 divided by 10. So the answer is, just a second. So the answer is 0.17497. So rounding it to 3 significant figures as required by our syllabus, it will be 0.0175 and the units kg. So this is the mass of the ring, 0.017. Is question 3. As shown in the diagram, a block of mass 10 kg is at rest on a rough plane at an angle of 30 degrees to the horizontal. A force of 120 newtons is applied to the block at an angle of 20 degrees above the line of greatest slope. There is a force resisting the block and 200 joules of work is done against this force when the block has moved a distance of 5 meters up the plane from rest. Find the speed of the block when it has moved a distance of 5 meters up the plane from rest. So, approaching these types of questions, we need to focus on the idea that energy is conserved, as we have already done in question 1. Energy is conserved. That means if energy is lost, another form of energy is gained. So, which energy is lost in this question? Let's look at the diagram. A 120 Newton force is dragging the block upwards. So since it's moving up, GPE is gained. So that is 1. Since the speed of the block is increasing from rest, since at rest it's 0, we can also say that kinetic energy is also gained. And then 200 joules of work is done against friction. So work is done against resistance. So I can say this one, 200, work done against the resistance. And all of this is being supplied by this 120 Newton force that is applied using a string, I guess. So to form the equation, I would just require the component of the 120 Newton force and then I'll be done. So which component do I take? Do I take the vertical component or do I take the component that is parallel to the slope? Since the block is moving parallel to the slope, it's not moving upwards, it's not moving perpendicularly upwards, I'll take the component that is parallel to the slope. So that is the horizontal component of the 120 Newton force. In this case, that is 120 cos 20. So this is the force that I'll be taking since it is in the direction of the force of motion. So keeping that in mind, I'll start to form my equation. Work done is just force into distance moved in the direction, which is 5 meters. So the force 120 cos 20 times 5. This is the energy lost since this force is doing work in order that GP is gained, K is gained, and work is done against friction. So this is equal to the GPE gained plus KE gained plus the 200. Now I just use the required formulas to adjust the equations, or I can also simplify it at the time. 120 to 5 is just 600. So 600 cos 20 is equal to GP gained. So that is mg del h plus KE gained. So half m. Since the velocity or the speed at the very beginning was 0, I can just say mv square plus 200. Now the mass of the block is given as 10 kg, so I can input that and also the change in height. I have the angle 30°, and I also know that the hypotenuse is 5 meters. So let's just find the height. So a 30° angle, a 5-meter hypotenuse, so the vertical height will be opposite to the 30° angle, so 5 sine 30. This is the height that the block moves upwards. Therefore I can form my equation. 600 cos 20 is equal to 10 times 10, the mass is 10, yes, 10 times 5 sine 30 plus half times 10 times v square plus 200. The main equation has been formed, and now I can move towards solving and finding v. So, or 600 cos 20, I'll just take the values towards the left, keeping v squared to the right. So 600 cos 20 minus 10 into 10 into 5 sine 30, which is 250, so minus 250, and then the 200. So 250 plus 200 is 450, so I'll write that. So this is equal to 5v square. Now I take 5 towards the left, so I can say or v square equals to 600 minus 450, 600 cos 20 minus 450 divided by 5, and keeping an exact value, I'll move and say v equals to root over 600 divided by 5 was 120, so 120 cos 20, and 450 divided by 5 is 90. So root over 120 cos 20 minus 90 is the velocity. Now just finding the value, 120 cos 20 minus 90. So the answer is 4.77 meters per second. This is the speed when the block has moved 5 meters up the plane. This is question 4. A particle P of mass 0.2 kg lies on rest on a rough horizontal plane. The horizontal force of 1.2 newtons is applied to P. Given that P is in limiting equilibrium, find the coefficient of friction between P and the plane. So before solving anything, let's just draw a rough sketch of what is happening. There is an object or a particle P of 0.2 kg mass, and a force is being applied of 1.2 newtons, and since it's on a rough horizontal plane, there must be a force of friction opposing this force of 1.2 newtons, so friction. And they stated that that P is in limiting equilibrium, so I can say that friction is equal to the 1.2 newton force. So given that friction is equal to 1.2. And they are asking us to find the coefficient of friction. So I know the formula of friction, which is F is equal to mu R, where R is the normal reaction force. R is the normal reaction. And this is nothing but the weight of the mass in most cases, unless a vertical force is acting on the object. So to solve this question, I just write mu times R. R is the normal reaction force, which is the upwards force. This force is countering the weight. The weight is 2 newtons, so the normal reaction force is also 2. So mu into 2 is equal to 1.2. Therefore, mu is equal to 1.2 by 2, 0.6. This is the coefficient of friction, or mu. Moving on, given that the particle given instead that the coefficient of friction between P and the plane is 0.3. Now they're giving us the coefficient. Find the distance traveled by P in the third second of its motion. We need to understand what they mean by the third second. Third second means from, let's say, t equals to 2 to t equals to 3. This time period, or the time between 2 and 3, is the third second. So now I need to find the resultant force. Since the coefficient decreased, it means P is moving and P is accelerating. So logically, the first step would be to find the acceleration of P. So to find the acceleration of P, I just find the resultant force and divide the mass. So F is equal to ma. The 1.2 Newton force remains unchanged. 1.2 minus the friction. Now the coefficient changed to 0.3 times mu. Mu is 0.3 times R. R remains the same, which is 2, equals to 0.2 A. Therefore, rearranging the equation 1.2 minus 0.3 into 2, I can say 0.6 divided by 0.2 is equal to A. Therefore, A equals to 0.6 by 0.2. A is equal to 3 meters per second squared. Since this is the new acceleration, since I have the acceleration now, which is 3 meters per second square, I can use multiple methods to find the distance traveled. Let's try to represent the motion using a velocity time graph. It started at rest, so it will pass through 0, and it has a constant acceleration of 3 meters per second, so the graph is a straight line. So 0, and we know they are asking for the distance traveled in the third second, so between 2 and 3. So what they're asking us is to find this area, the area under the graph of velocity time graph between 2 and 3. So to find that, I'll just find the velocities at each of these times, or I could use another equation using the equations of motion. So at t equals to 2, s is equal to ut plus half at square, u is 0 since it started at rest, t is 2, so s is equal to half times 3 times 4. 2 squared is just 4, and when t equals to 3, s is equal to half times 3 times 9. So I have the displacements at each of these seconds, or each of these times. So now I can just find the distance traveled in the third second using the difference of these two. So difference between S2 and S3, I'll label them as S2 and S3. So S3 minus S2 is the total distance traveled in the third second. Distance in third second. Therefore, the distance is, so half into 3 into 9 is 13.5. 13.5 minus half into 3 into 4, that is 6. So 13.5 minus 6, the distance is 7.5 meters. This is question 5. A particle A of mass 0.5 kg is projected vertically upwards from the horizontal ground with a speed of 25 meters per second. Find the speed of A when it reaches a height of 20 meters above the ground. So before solving the question, let's just draw a diagram to show what's happening. There is a particle, it's moving upwards. The initial speed u equals to 25 meters per second. We have its mass 0.5 kg, and they're asking us to find the velocity. They're asking us to find the velocity when it's at a height of 20 meters above the ground. So let's look at the information they have given us. We have the initial velocity, we have the height, and since the weight is the only force acting on the object, 5 Newton weight, the acceleration will be due to gravity. So acceleration, or in this case deceleration, since the weight and the velocity is in opposite directions, so the deceleration is 10. Deceleration equals to 10. So considering the information given to us and the fact that they're asking us to find the velocity, we'll need to use the equations of motion. Equations of motion. And the best one to use in this case will be v square equals to u square plus 2as. Because we already have u, we have a, we have s, we just need to find v. So let's input the values. So v square equals to u square, which is 25 square, plus 2 times. Now, since the ball or the particle is going to decelerate, we use minus 10 as the acceleration, since the acceleration and the initial velocity are in opposite directions. We are taking upwards as the positive and downwards as the negative. So minus 10 times the height 20. Now we just simplify and solve for v. So v square equals to 25 square plus 2 into minus 10 times 20. That's 225. Therefore, v equals to root 225 equals to 15 meters per second. Moving on, when A reaches a height of 20 meters, it collides with a particle B of mass 0.3 kg, which is moving downwards in the same vertical line as A with a speed of 32.5 meters per second. In the collision between the two particles, B is brought to an instantaneous rest. Show that the velocity of A immediately after collision is 4.5 meters per second downwards. So when reading this question, you will notice that I highlighted the important parts. We need to understand what method we'll approach to solve this question. So let's look at the fact. What's happening? There is a particle that was moving up, and when it's at a height of 20 meters above the ground, it collides with another particle, which is being represented as B. So two particles are colliding. Whenever we see questions related to collision, and there are velocities before and after collision, velocities before and after, we need to understand that this is a question of momentum. So we have figured out that we are going to use momentum to solve this question. So we know that momentum is conserved throughout. So momentum before equals to momentum after. Equals to momentum after. So if we just form an equation for momentum of the collision, we'll be able to solve this question. So particle A was at a speed of 15 meters when it reached the height of 15 meters per second when it reached the height of 20 meters. So the mass of A was 0.5 times its velocity, 15. We're taking upwards as the positive direction and downwards as the negative direction. Since B was moving downwards, we'll use a minus 0.3 times 32.5 equals to B was brought to an instantaneous rest. So the velocity of B immediately after collision is 0. So we can just write a 0 for that. And A, we don't know the direction of the velocity, so we'll just use V to represent that. So plus 0.5 V. Now if we solve for V, we'll get the velocity, and the sign will determine the direction. Determines direction. So now if we just continue solving this question for V, we'll be moving to our solution. Therefore, 0.5 times 15 minus 0.3 times 32.5, that's minus 2.25 equals to 0.5 V. Therefore, V equals to minus 2.25 by 0.5 equals to minus 4.5 meters per second. So we showed 4.5, and this minus sign, this shows downwards motion. So that is for part B. Moving on. Find the time interval between A and B reaching the ground. You should assume A does not bounce when it reaches the ground. This information is not really necessary. We'll need to focus on the first sentence. So we know that even after they collide, A has a velocity downwards. B, despite being at an instantaneous rest, it will eventually move downwards because of its weight. Due to weight. So the only force is the weight. So the acceleration will be equal to 10. Acceleration equals to 10. And the distance they're moving downwards is 20 meters. So we have a height, we have the acceleration, we have the initial speeds of both. For B it was 0, and for A it was 4.5 meters per second. So looking at that information and the fact that they're asking us to find a time, the best equation of motion to use, will be S equals ut plus half at squared. Because if you look, we have the value of S, which is 20, we have U, we have A. All we need to find out is T. So let's find T for the first particle A. So for A, the height is 20. It is equal to ut, so 4.5t plus half times 10 times t squared. So simplifying this equation, we get 5t squared plus 4.5t minus 20 is equal to 0. Now we just solve this quadratic. So 10t squared plus 9t minus 40 is equal to 0. If we do middle term factorization, The values we can take are 16 and 25. So 10t square plus 25t minus 16t minus 40 equals to 0. Or let's just solve this question. 5t common, 2t plus 5 minus, let's take 8 common, so 2t and plus 5 equals to 0. Therefore t is equal to minus 2.5, or t is equal to minus 8 by 5, which is just 1.6. Now the time can never be negative, so minus 2.5 will not be an answer, so we can just write not applicable right here. And now we need to find for b. So to find for b, the process is again the same. The height is 20, their initial velocity in this time is 0, plus half a t squared, so half into 10 into t squared. This is much simpler. So 40 by 10 is equal to t squared, or t squared equals to 4, therefore t is equal to 2. So I have the time intervals for both b and for a. So the time interval will be just the time b took minus the time taken by a. Time b minus time a, which is equal to 2 minus 1.6 is equal to 0.4 seconds. This is the time interval. Is question 6. A railway engine of mass 120,000 kg is towing a coach of mass 60,000 kg up a straight inclined track at an angle of alpha to the horizontal, where sine alpha is 0.02. There is a light rigid coupling parallel to the track connecting the engine and coach. The driving force produced by the engine is 125,000 Newton, and there are constant resistances to the motion of 22,000 Newton on the engine and 13,000 on the coach. Find the acceleration of the engine and find the tension in the coupling. So let's draw a diagram to represent what is happening. There is an inclined plane of an angle of alpha to the horizontal. Sine alpha is already provided to us, which is 0.02. So there is a railway engine, let's represent that using a square, that is pulling a coach. I'll use a circle to represent that. So engine, coach, and the driving force is of 125,000 newtons upwards, and the other forces are the weight components. I'll use mg sine alpha for both. I'll use mg sine alpha for the engine, mg sine alpha, and mg sine alpha for the coach. We also have the resistances for both. So there is a resistance acting on E, and there is a resistance acting on C. And lastly, they mentioned that there is a tension in the coupling. So we need to determine the direction of tension for both. So the coach is being pulled upwards, and the only way that it can be pulled upwards is if tension is upwards for C, because the bar is connecting the engine and the coach, and the tension in the bar is pulling C upwards. So since for C it's upwards, for E it must be downwards. So we have determined the direction of forces acting for both the coach and the engine. So now we need to understand something called systems. So systems are basically just taking multiple bodies and determining the direction of forces and finding the overall acceleration. So we have three systems in this question. one is just the engine, the second one is just the coach, and the third one is the engine and coach combined. Engine and coach. For this question, I'll take the first system and the third system to solve this question. So, what are the forces acting on the engine? We have its weight component. Let's write it. mg sine alpha. We have tension. We have the driving force. Let's use Fd. And we have the resistance. These are the forces acting on the engine. So let's form an equation. We already know that it's accelerating, so we must be using F equals ma. So the forward force is the driving force, as we can already see in the diagram. This and mg sine alpha is downwards. So let's look at the mass. It was 120,000. So minus 120,000 times 10 times sine alpha. The value is already given as 0.02. So 0.02 mg sine alpha. So that is 1 down. The driving force is also down. We need to use the resistance. The resistance was 22,000. So minus 22,000. And lastly, the tension. We already determined that the tension is downwards. So this equation is used to find the resultant force, which is equal to mass into acceleration. So 120,000 times A. So this is for system 1. We have the driving force minus mg sine alpha minus the resistance minus the tension to find the resultant force, which is equal to mass into acceleration, ma. So this is for system 1. We can notice that there are two variables, t and a, which means we need to form simultaneous equations to solve this question. And as previously mentioned, I'm going to use system 3. The reason for system 3 is because if we consider the coach and engine as one, we'll notice that the tension cancel out because one is forwards and the other one is backwards. So overall, the forwards and backwards cancel out. So the tension, we can consider T as 0 for the whole system. In that case, the only forces we need to focus are the driving force, mg sine alpha, the weight component, and the total resistance. We need to focus only on these three forces. So let's form our equation. 125,000 minus, so 125,000 minus the weight component. The total mass was 180,000. So I can just combine and solve. So 180,000 times 10 times 0.02 minus the total resistance. It was 22,000 Newton on the engine and 13,000 on the coach. So minus 22 and 13 will give us 13,000 is equal to mass into acceleration. And when looking at this equation, we can notice that this has only one variable a, so this can already be solved. So let's move on and solve. We are just going to simplify the equation and solve as required. So the resultant force is 54,000. This is equal to 180,000 A. Therefore, A is equal to 54,000 divided by 180,000 divided by 180,000. So the acceleration is 0.3 meters per second squared. So we have found A. So now we can actually move back to the first equation, which had two variables. Since we already found A, we just need to rearrange the equation and solve for t. So let's simplify. 125 minus 120 times 10 times 0.02 minus 22,000. So 79,000 minus t is equal to, now we'll input the value of a times 0.3. Therefore, t is equal to 79,000 minus 120,000. Let's find the value, times 0.3. So 79,000 minus 36,000. So t is equal to 79,000 minus 36,000. We get 43,000 newtons. That is the value of tension. Moving on, at an instant when the engine is traveling at 30 meters per second, it comes to a section of track inclined upwards at an angle beta to the horizontal. The power produced by the engine is now 4.5 million watts, and as a result, the engine maintains a constant speed. Assuming that the resistance forces remain unchanged, find the value of beta. So, since the question states clearly that it's moving at a constant speed, we can say that the resultant force is 0. Resultant force equals to 0. So the forwards and backwards force will cancel out and be 0. And the information given to us is the speed and the power. So power is equal to force into the speed. So we can already use that to find the driving force. So let's find that. 0.5 million is equal to 30F. Therefore, F is equal to 150,000. Is equal to 150,000. Just to be sure. Yes. So the driving force is 150,000. I've already found that before actually approaching the question, but let's draw a diagram. We have the same truck, we have the same engine and the same coach, E and C. They're still moving upwards, so all the forces remain the same. There is a driving force of Fd, there is the weight component, and the resistances, which remain the same. We also have the tension, but this question doesn't focus on tension anymore, so we need to understand that we are taking the whole system now, because previously in the first part we determined that in system 3 the engine and coach combined, the tension cancel out since they're in opposite directions. So we'll be using system 3 to solve this question. System 3. So again, just to recap, we know that the resultant force is equal to 0. The driving force is still upwards, the weight components are downwards, and the resistances are downwards, opposing the driving force. We already found the driving force as 150,000 newtons, so we can just form the equation that Fd minus mg sine beta minus the resistances will be equal to 0. So to solve the equation, we just input the values as required, minus the total mass we already figured out was 180,000 times 10 sine beta minus the total resistance 22,000 minus 13,000 equals to 0. So now we just rearrange the equation and solve for sine beta. So 150,000 minus 22,000 minus 13,000 is 11,500, 1,115,000. Sorry, I'll just write that. This is equal to 180,000 sine beta Now we just take 1.8 million to the other side. So sine beta is equal to 115,000 divided by 18123 5 zeros. Now we just solve for beta. Beta equals to sine inverse the value we previously found, 115,000 divided by 180. So that was 23 by 360. So sine inverse 23 by 360. We get 3.66 degrees. Now, according to our syllabus, all answers or angles that are in degrees must be mentioned to one decimal place, 1 dp. So we need to round this value to 3.7 degrees since 6. So 3.7 degrees is the answer. This is question 7. A particle x travels in a straight line. The velocity of x at time t seconds after leaving a fixed point O is denoted by v meters per second. We have the equation of v given to us. The acceleration of x is 0 at times t equals p and t equals q, where p is less than q. Find the value of p and the value of q. So we already know acceleration is the rate of change of velocity. So acceleration is dv by dt, which means we just differentiate v with respect to t. So if we're going to differentiate, so minus 0.1 into 3 t squared plus 2 into 1.8t minus 6. This is equal to 0 because they already stated that acceleration of x is 0 at p and q. So now we just simplify and solve for t to get the value. So minus 0.3 t squared plus 3.6t minus 6 equals to 0. Let's divide the whole thing with minus 0.3. So t squared plus 3.6 divided by minus 0.3. That is 12 minus 12t, and then 6 divided by minus 0.3 will be 20. So plus 20 is equal to 0. Now just middle term factorization and solving. So 12, the value we can choose are 10 and 2. So 10 squared t squared minus 10t minus 2t plus 20 is equal to 0, or t minus 10 minus 2 common, t minus 10 is equal to 0. Therefore t is equal to 2, t is equal to 10. And since they have already stated that p is less than q, so p is equal to 2 and q is equal to 10. Moving on, it is given that the velocity of x is 0 at t equals to 14. Find the velocities of x at t equals p and t equals q. Hence, sketch the velocity time graph for the motion from 0 to 15. If we look back at the velocity equation given to us, we can already have an idea of the shape of the graph. It's a cubic equation, t cube, and the coefficient is minus. So the shape will be downwards initially and then it will move upwards. So the shape will be like this. So we have an idea of the shape already, but let's find the velocities as they have asked us to find the velocity at p and q. So to find the velocity, we just input the value. So t equals to 2. So minus 0.1, 2 cube. Let's look at the equation. Plus 1.8, 2 square. Look at minus 6 times 2 plus 5.6. So if we solve, the value we get is 2 cube plus 1.8 into 2 square minus 6 into 2 plus 5.6, which is 0. So we have already solved for p, now solving for q. So t equals to 10, or let's use a different color for that. T equals to 10. So again, the same equation, just a different value. 0.8 10 square minus 6 times 10 plus 5.6. So if we just replace the value in the equation, we get 25.6 meters per second. So 0 and 25.6. We've already found the velocities. Now let's sketch the graph. We draw the required axes. So this is for time, this is for velocity. 0 at the beginning. So where do we start our graph? We start at 0, obviously. So when t equals to 0, all of this becomes 0. We just have 5.6. So it starts at 5.6. And then we already know that cubic curves or cubic graphs equations have 3 roots. But we only found 2 times where v equals to 0. This means the shape of the graph will be something like this. A root is being repeated. So we know the value of v is 0 at t equals 2 and t equals 14, and we also need to show 15 over here, and at 10, let's show 10 somewhere over here, the value was 25.6. So if you want to draw the sketch now, it will go downwards first and then it will move up and then it goes down again. If you want to draw a better sketch, let's just adjust 14. So it goes down, then it goes up, then it goes down again. This is a sketch of the velocity time graph. We need to understand that we only have 2 times where v equals to 0. That means one root is being repeated, which is 2. Since we know that at t equals 10, the velocity increases, because let's say 14 was the repeated root. Then the graph would be something like this. But we know the velocity is positive at 10, whereas this one was negative. So this graph was wrong. 2 was the repeated root, not 14. Not 14. Moving on. Find the total distance traveled by x between t equals to 0 and t equals to 15. So since they're asking us to find the distance, we just find the area under the graph for the given range, t equals to 10 and t equals to 15. So let's look at the areas. We have this region from 0 to 2, that is a positive area, so no problem. We have this region from 2 to 14, another positive area, so we don't have a problem with that. But there is a region from 14 to 15 which is under the graph, so negative. But they asked us to find the total distance traveled, so we need to consider the negative value as a modulus and take the positive value, take the magnitude to be exact. And since this question is about area under the graph equals to the distance, so we need to use integration. Now which equation do we integrate? We integrate the velocity integration, because velocity integration with respect to time is equal to the displacement. And if we look at the graph, we can take one limits 1 as 0 to 14, since the area is positive for both 0 to 2 and 2 to 14, and then limits 2 will be from 14 to 15. So 0 to 14 and 14 to 15. So let's first integrate the equation. Minus 0.1 t cube plus, what's the equation, 1.8 t square minus 6t plus 5.6. So integration dt, this is equal to minus 0.1 t to the power 4 by 4 plus 1.8 t cube by 3 minus 6t square by 2 plus 5.6 t plus c. Now we already know that when t equals to 0, s is equal to 0 because it starts at O. S is equal to 0 because it starts at O. So the whole thing would be 0, so c must be 0. So we can just ignore c. So we have the integrated equation. Now let's just input the limits. Limits 1, which was 0 t 14. So if we input 0, the whole thing just becomes 0. So we can just input 14 in this equation. But just to write it properly, let's simplify the equation first. So minus 0.1 divided by 4 would be minus 0.025 t cube plus 1.8 divided by 3 is 0.6. So 0.6 t cube minus 3t square plus 5.6 t. The limits are 14 and 0. So this is equal to, now we input 14 first. I'll just input that in my calculator and write the whole value. Minus 3 into 14 square plus 5.6 into 14. So the value I get when putting 14 is 176.4, and when I input 0 I'll get a 0, so it's 176.4. So from 0 to 14 the distance traveled was 176.4 meters. Now for limits 2, we know that when we input limits 2 we'll be getting a negative area, so we need to remember that. So again the same equation, plus 5.60. The limits are now 15 and 14. We already know that when we input 14 we get 176.4, so we just input 15 now. So if we just replace everything with 15, we get 168.375 minus 176.4, and we get 176.4 minus, we get minus 8.025. We get the minus because the area was under the graph. We will just take the magnitude, we can consider it a modulus, so 8.025 meters. So the total distance traveled, let's use a different color, total distance traveled will be equal to 176.4 plus 8.025. Thus the final answer is 184.425 meters. That is the total distance